Okay, so in this presentation what we're going to do, this is for a discrete random variable. So we consider the following probability distribution for variable x. So we have 4 outcomes there, 1, 2, 3, and 4. And we have 4 probabilities there for each of each outcomes, but we have 0.2 for outcome 1, 0.25 for outcome 2. We have k, some value k for outcome 3, and 0.3 for outcome 4. So essentially what we have to do here is we've got 4 questions, okay? Consider the following, or calculate the following: the value of k, the expected value of x, the variance of x, and the standard deviation of x. Okay, so all the sort of fundamentals. Now, the first question is actually very straightforward. I'll just put it up into screen there, okay? The sum of the probabilities must add up to 1 for it to be a proper probability distribution, okay? So 0.2 plus 0.12 plus k plus 0.3 must equal to 1. Otherwise, it's not a proper probability distribution, okay? So if you add up 0.2 to 0.25 to 0.3, that would, and then just leave k aside, we can actually re-express the left-hand side as k plus 0.75 is equal to 1. And necessarily, k therefore must be equal to 0.25. Okay, so that's the first one done, okay? Simple enough. All of these values must add up to 1. Okay. So what I'm going to do now is calculate the expected value of x. Okay, which we denote e of x. Okay. And what we do here is I have a guide, the table just rewritten up here with the value of k written in as 0.25. This is the formula we're going to use. Essentially what we're going to do here is multiply the value x by the outcome by the probability of that outcome and sum them all up. Okay? So essentially what we're going to do here is multiply 0.2 by 1, or actually I have it there as 0.2 by 1, but correctly I should have it as 1 by 0.2 because I just accidentally switched the order there. I should not have really done that. It doesn't affect the outcome. But I'll just call it out. 1 times 0.2 plus 2 times 0.25 plus 3 times 0.25 plus 4 times 0.30. Okay? So when I work it out, all those values there, okay, just consider that as workings. I get 0.2 plus 0.5 plus 0.75 plus 1.20. Add them all up, and I get 2.65. So the expected value of x is 2.65. Now, the next question is calculate the variance of x. But we've got a job to do beforehand. Now, I'll actually just get straight into this job, first off, okay? What we have to do here is calculate this is an important feature of calculating variance for discrete random variables. I'll come back to it shortly, but this is an important step. And I'll just show you how it fits in the overall formula and the overall scheme of things later on. But we have to calculate this, the expected value of x squared. So rather than calculate the expected value of x, what we do here is x squared. It's a very similar calculation to what we've done above, but all we have to do is actually square the outcomes and multiply by their probabilities. So the outcomes were 1, 2, 3, and 4. And rather than multiply the outcomes by the probability, we multiplied the square of the outcomes by the probability. 1 squared times 0.2 plus 2 squared times 0.25 plus 3 squared times 0.25 plus 4 squared times 0.30. Okay. And when we tot that up, there we go. 1 times 0.2, 4 times 0.25, 9 times 0.25, 16 times 0.30. Add up all of those values, we get 0.20 plus 1 plus 2.25 plus 4.80. Add all of those up and we get 8.25. Now that is not the answer. That is just the expected value of x squared. Now the reason is why, I'll just put that back in the shot there. The reason is that it's an important calculation in calculating the variance of x. Now this is a formula that you've really got to know. This is the calculation the expected value of a discrete random variable. Okay, importantly, discrete random variables, just only discrete random variables. So what we have to do here, the formula is as follows: the variance of x is equal to the expected value of x squared minus the expected value of x to be squared. Okay, so we have 8.25. Okay, minus 2.85 to be squared. Now just watch that important difference there, okay? It is Two very, very different values. Now remember, this is x squared in the bracket. This is the expected value of x to be squared. It's almost, you can actually, let's put a bracket around the e to the x there, okay? So that's just a very important difference. They're not the same, essentially. This is not the same as this. Anyway, I digress. So this is just a bit of calculator work. 8.25 minus 2.65 squared, that is 8.25 minus 7.0225 squared, which is 1.2275. Okay, that is the answer to the variance of x, 1.2275. Now, the last question is essentially a short enough one. What is the standard deviation of x? That is the square root of the variance, which is approximately 1.107. That's all. Just have to remember that the standard deviation is the square root of the variance. Okay, that's that video done. Okay.